Oh, all right. It's my pleasure to introduce Ngiam, who's the Director of Engineering at Coursera. As many of you are familiar with, University of Illinois just started using Coursera this fall. Is anybody here taking a Coursera class? Cool. I'm registered in one, but it hasn't started yet, so maybe soon. Ngiam works at the crossroads of machine learning, education, and large-scale systems. He obtained an MS in computer science at Stanford University and a BS from Carnegie Mellon University. In fall 2011, he led the efforts in creating a massive online class in machine learning, which transitioned into Coursera. He now directs the Coursera engineering efforts to help change the world through education. Please lend a warm welcome.
Cool, thanks. And really great to see that UofI is part of the partnership and that you guys are taking Coursera classes. So today kind of wanted to tell a bit more about the history of Coursera, kind of give a sense of where we came from, and also give a bit of the insight into the technology and what we're doing at Coursera. So kind of what happened last year, it's around this time last year. So my advisor, Andrew Ng, I'm currently the co-founder of Coursera, he came to me asking me, hey, what do you think about setting up an online class and getting anyone in the world to sign up for it? So this was like around late July last year. And I was like, hey, that sounds really cool. Why don't we do it? And I got together with two or three other undergrads, and we set up a really simple web page, a really ghetto page, with a sign-up box with your email and your name. You can click sign up for it, and then we'll get your email and name and have a sign that you're interested in taking the class. So this was in early August, late July last year. And what was surprising to us was that within days, just 2 or 3 days of putting up this simple website that took in your name and email address, we had over 2,000 signups in 2 or 3 days. And after 2 or 3 weeks, we had about 20,000 people enrolled in the visible online form. And then we started getting worried. It's like, oh, this is in July, right? So it's like, the class is going to start in October, and we have not done anything yet. And so in mid-August, we were like, let's get our act together. We had to put up a real class for the 20,000 people that were interested in taking machine learning online. So in the span of just 2 months, from August to October, a team of 4 of us got together and put together what was known as the machine learning class back then. So this is what it looked like. So just in 2 months, a few of us got together and put it up. What was interesting what happened that was interesting that when they went into building this site was that we wanted to rethink about how education and courses could be taught online. So unlike the traditional video lectures that you get online that have a professor speaking into a classroom in the video, we wanted to rethink how online learning should be taught and should happen. And to do that, we put together a few things. So the first thing that we did was we thought about how content should be contributed to be taught online. So this is a lecture video from the machine learning class that demonstrates what that looks like. So in all the lecture content for the machine learning class, they were all rebuilt from scratch, and they were all in this format that was designed to be much more personal and one-to-one with the student. So what you're seeing here is an example from the lecture slides where the instructor is annotating using a tablet on a PowerPoint slide the material he's describing and explaining as he goes along. So this was the first thing that we did, rebuild the content and make it really interactive and personal. But what we also realized was that an online class needs to have really good assessments for students to evaluate themselves and make sure that they're learning the right things. So for these, we also put in normal assessment types that you would expect, multiple choice questions like this, where you can pick one of the check boxes. But what we also did was to go a further step forward in assessments and also had programming assessments for students to complete. So through the course of the 10-week machine learning course, every week students had to complete an assignment that involved either implementing, say, an SVM, implementing backpropagation and neural networks, collaborative filtering, or even things like logistic regression. So these were actually real programming assignments where you had to complete MATLAB functions, and they were all auto-graded based on our system. So it was a really hard class. So I spent many sleepless nights actually writing up all the documents and the framework for grading this. So if you haven't taken machine learning yet, highly recommend it. Thanks. And one of the most astounding things that happened back then was the amount of traction that we got in these classes. So in the span of from July through October to December, we picked up 122,000 students on the website, which generated 19 million page views, close to 20 million actually, almost 9.8 million video views, 800,000 quiz submissions, and 34,000 forum posts. You know, kind of think about it in retrospective. This was back then probably the single biggest experiment in education. Right? There's not been a class with that many students, that many quiz submissions, and that many discussions going on. And what was really cool about this was that out of the 122,000 students, about 13,000 of them successfully completed the class. So about 20,000 of them went through all the assignments, did all the programming exercises, implemented all the algorithms in Octave, and then made sure that through our automated evaluation system, got the right solutions. So that was amazing. And so this was an experiment from Stanford University. So it turns out that the machine learning class at Stanford is one of the most popular classes. So, at Stanford, this class often attracts up to 400 students every year. And every year, the classrooms would be full of people because everyone wanted to learn about machine learning and big data and processing. But what was incredible is that in 3 months, what we could do was to teach 100,000 students. Right? So education at scale. And if we were to actually do the same mode of education in the classroom, it would have taken us about 250 years, doing the math, 100,000 divided by 400, to reach the same number of people here. So, technology can really, this really occurred to us that technology can really improve the way we teach. So this experiment was in Stanford, and so this was the machine learning course where we had 100,000 plus students, and we also had a database class and the AI class running back then. So given the successes of these experiments, we then went on to transform this whole project into Coursera. So from here, we went on to, in April earlier this year, we launched up with 4 partners, Princeton, Michigan, Penn, and Stanford, launched 40 plus classes. And then in July, we grew rapidly and got on up to 16 partnerships with all various schools here, including U of I is one of them. So this in July, we had over 100 classes, and just barely 3 weeks ago, we announced even more partnerships, and we're now up to 33 universities and 198 classes. So it's been a pretty incredible growth in terms of the number of professors, the high quality education and courses we have been offering on the site. So since I'm at UOI, I'd like to give a shout out to the UOI professors and classes that you're running here. So there's some really interesting classes coming from the UOI. In particular, the one on top there, Lawrence Ongrave is teaching a class on Android application programming, and also there's Wenmei Hu who's teaching GPU programming, which I think are 2 really exciting classes. Also, Rob Ruthenberg is teaching a class on logic to layout. Might be interesting too. Cool. So I've shown you the growth in number of classes and number of institutions that we have onboarded. And parallel to that, what we've also seen is an incredible amount of growth in our user base. So what we're seeing here is the growth of the Coursera user base as a function of time. So sometimes it's hard to sometimes it's easy to forget that Coursera has only been around for barely 8 months. And so in 18 April, we have the company launch, where we see a little spike in growth. And then in 17 July, the growth goes further, and 18 September recently, we have even more courses. So the red line here represents the number of enrollments in the classes, while the blue line represents the number of unique students. So on average, we have about 1-to-3 ratio right now of users to course enrollments. So each user is taking more than 1 course. Cool. And I think what this graph really speaks to is the fact that there's a huge demand in education, or demand in having these classes, access to these classes. And I'm really glad that Coursera and other people in the field now are stepping in to fill this demand. Perhaps one thing I didn't mention here was that so far in the last 8 months, we have done virtually no marketing or try to kind of spread it virally. And this is all just word of mouth and organic growth. I can't imagine what it would be like if we do marketing in this. Just go crazy. So where are these people coming from? So let's see. So this is a graph of demographics of our users, just to give a sense of where things are. And it turns out that the US, of course, being where we started from, is one of the biggest consumers of our product. So about 34% of our users are from the US, and the majority of the audience turns out to be actually international. So about 65% of our audience are international from all over the world. So over here, India and Russia are actually 2 of the biggest countries in the map too. And to me, what's really gratifying here is that we're bringing people from all over the world together to the same place, to take courses together and to share and exchange ideas. Never have we actually brought that many people together before. And over here, I'd like to show you a little snapshot on how, what course enrollments look like. So I've been talking about these online big courses, but what do they look like? Which courses are more popular than the rest? So over here, I'm seeing a graph. Oh, there's no labels, but of the course enrollments, and every column is a course, and the height of it represents the number of enrollments in the course. Would anyone venture to guess what the course up here is? Getting close. Turns out to be Intro to Finance. So not surprising, I guess. So everyone wants to know, finance is probably the most hot topic now. So this is a snapshot taken about, say, 2 months ago on the courses on the platform, where the blue indicates, a batch of courses in July, I think, and the red indicates a batch of courses that were announced in April. So we have courses across the whole spectrum, from organic chemistry, taught by Jeff Moore right here, to thinking and reasoning and arguing, to machine learning, and of course our most popular class, Intro to Finance. Yeah. And for those of you who are actually interested in learning how to feed your horses and ponies, there's even a course on equine nutrition, so you can learn how to do that if you have any horses. Sorry.
Are you offering any courses over the summer?
Oh yeah. So the question was whether we plan to offer any courses in summer or winter. So it turns out that in the online model, I think the framework to think about this is that there's not really a schedule or summer, winter, quarter. And I think we want to offer courses all around all time, in all quarters. And any month there are courses running, you can join them. So yes, we plan to do that. Yeah, cool. So for those of you who are not that familiar with Coursera, I'm going to show you a quick short video clip to let you give a sense of what it's like.
Welcome to Calculus. 50 million people are uninsured.
Models help us organize information. They help us make better predictions. They help us design more effective institutions and policies.
And if we run this, we get unbelievable segregation.
So Bush imagined that in the future, you'd wear a camera right in the center of your head.
Mills wants the student of sociology to develop the quality of mind that grasps the interplay.
Hanging cable takes on the form of a hyperbolic cosine.
For each pixel in the image, set the red to 0. So let's see what that looks like.
And that vaccine allowed us to eliminate poliovirus.
Does Lufthansa serve breakfast in San Jose? Well, that sounds funny.
So this is which coin you pick, and this is the 2 tosses.
0 from being passive, so passive becomes a best response.
So in large-scale machine learning, we'd like to come up with computational...
So hope that makes you want to take some classes. So a sneak peek into the classes, and what I actually like to talk about next is what goes into these classes. What do we do at Coursera, and what do we think about them? So I'd like to talk about the 4 key ingredients that go into them: a schedule, video lectures, assessments, and community interaction, and then give you an insight into the technical parts of it that go behind this. So on Coursera, all the classes are what we think of as real online classes when the whole full course experience is put online. So over here, I'm going to show you what a class looks like. So all our classes have a particular start date, say sometime in September, and the course begins, and then it runs its duration for about 8 to 10 weeks. And what you're seeing here is the real statistics from the ML class that ran in fall 2011. So over here, what you notice is that there's this nice spiky pattern in the graph, where the graph is showing the number of users on our site. And what's interesting is that every spike that you see here that goes up and down actually corresponds exactly to a deadline for the homework. so at least at Coursera, we know when our loads are high. That's when homeworks are due. So and then what's interesting is that this shows us that procrastination, I guess, is an international phenomenon. Yeah, cool. And it turns out that more seriously, a good part of online education in the past, I guess, has always been a very self-paced mode, where you're always, you're able to do the assignments anytime you like, and you can always say, I'll do it tomorrow, and I'll do it tomorrow, and tomorrow becomes tomorrow, and you never do it. And having a schedule, having a guidance to a student, telling them, when they should do something, when they should get their work done, is really important as a motivation factor to get it done. And if the whole class is in the same cohort, moving on with the material, you really want to catch up with them and do the same, be at the same pace as everyone else in the class. And so this whole schedule thing is really important for online education. And of course, at the end of the class, our students can also get a little certificate of accomplishment that indicates that they have completed the class, and over 10,000 students in the machine learning class got the certificate. Cool. So that's the first thing in the class. Having a schedule is really important. The next thing in the class, is the next part of the next important piece in the online class is actually content, having video. And while we all have video lectures and we have all seen online video playback before, what I'd like to show you in Coursera lectures is something interesting that we have developed, what we call in-video quizzes. So let me just show you that to you first.
These 4 things: prospect theory, hyperbolic discount,
so
status
this is the
bias,
example lecture, and what you can see here as the play bar hits the yellow marker there,
rational behavior.
The video will pause, and there's this in-video experience that you get, that you are answering a question that the lecturer has posed at a point of time. So the analogy to this is, when in a normal classroom, when a lecturer is in front talking to the students, somewhere in the middle of the lecture, they might, ask, hey, this is a question, does anyone know the answer to, what happened in this world history event? And then what the lecturer will look up and see that some people in the back row are on Facebook trying to, message their friends. Some people in the middle row are struggling to stay awake. And then there's be this really smart young kid in the front raising his hand excitedly trying to get the answer. And then of course the guy in the front knows the answer and the lecturer feels happy about it and moves on. But wouldn't it be great if all students, everyone in the classroom, was able to experience that question and answer moment? Wouldn't it be great if everyone could be engaged in that point of time, having a chance to answer the question? And I think online education, online video watching with in-video quizzes will allow us to do that. That's the next part. So, and the next big thing in online education, online courses, I think is really comes to meaningful assessments. So not just having content, but actually being able to synthesize the content and make sure you understand that it's as important as learning it. So as with all online platforms, we have the usual multiple choice numerical and short answer questions that we use regular expressions to check. But on top of that, we also have a few additional advanced assessment types that I'd like to share with you. So there's things like math expressions that we can check with. There's programming and modeling assignments, and open-ended assessments that we also support. And I think the really advanced assessment part of Coursera is one of the biggest things that we've invested in, which I think is a critical thing for online education to scale. So let me give you a peek into each of these 3 things. So for math expressions, this is an example from one of the classes where the question is to say, what is the derivative of sine x over x with respect to x? Right? And the answer is, this formula here, which is somewhat complicated, right? It's x cos x minus sine x over x squared. And what's interesting to note is that there are many ways to express this formula. You could say it's minus x plus x cos x. You can say it's x times x in the denominator. There's so many ways to do it. And for a student, right, we really want to keep the experience in a way that is really intuitive for them to enter the expression. So at Coursera, what we've done is to develop a technology to allow students to enter formulas in almost any format. They can then preview the formula to see what we are interpreting it to be, and then they can submit their answers and check whether they got it right. Like this. So let me show you another example here. So this is another example where you have to integrate the indefinite integral cos x plus x. Again, you can enter it in any different ways, and then you can make sure that you get it right. So how do we do this in the back end, I guess? So 2 technologies go in here. The first thing that we try to do is to try to symbolically manipulate the expression you enter and to reduce it to a canonical form. And if that symbolic manipulation results in the same expression as the instructor's expression, you get it right. But upon that not working, or upon that the symbolic manipulation failing, what we do is then to do many unit tests, like very small numerical tests, to make sure that you get the right answer there. Cool. Sorry, you have a question? Yeah. So the question is, what are we using to display the math there? And it turns out that we're using math jacks. So math jacks would render as mathml in Firefox. So it is part of mathml. Cool. So the other thing that we support as well, and one of the things that we do, is programming assessments. So for the classes that are more CS-based, we support programming assignments in any language, R, Python, MATLAB, and Java, and allow them to do advanced assessments on them, such as timing, memory usage, test set accuracy, and so on. So the GPU programming class from Illinois, for example, is you're going to use this whole framework to do GPU programming exercises. And the way we have this, way we enable this to work for instructors is actually to have an API for them to use. So the student will interact with the Coursera platform through an API, and then they submit the solutions, and then the grading service that any instructor can write, and then write their own advanced graders, can also interact with the API And we provide this interface with a back-end queuing system. So what is really interesting here is, is all the thought that's gone into how do we run code securely for the student. For example, if you're doing a coding exercise in Java or in C, how do you actually compile the student's code, make sure it's not doing anything bad, not trying to send emails to 1,000 users? How can we do all of that? So, and how do we scale this whole system up? So that's a huge challenge in programming assignments. Okay. So I'm going to show you another video again. And this one is going to be a more in-browser programming assignment. Hope you can see it, where the students are coding in the browser in a JavaScript-like language to correct the pixels in the image. So in this example, what the instructor here did was to set up a, let's see, play that again, or that I talk about it. The instructor here created a language that's a JavaScript-like that allowed the students to, in the browser, immediately get feedback on what they were doing. Right. So this was an example from the Introduction to CS class that we have on the platform. So again, there's a wide variety of assessments and interaction that we want to support for all the classes that we have. Cool. So, but I showed you a bunch of examples that get at evaluating what the correct answer is, right? So it's often easier to it's often easy to say that's the answer and then evaluate the students, how the student actually what they actually report as the correct their submitted answer. But how about the process in between? How do they get from what they know to the answer? And sometimes that process of proving stuff, of actually thinking through the steps that get there, is really important. And over here, I'm going to show you a little tip my toes into what we have done with mathematical derivations and proof checking. So in this example here, what we're looking at is many ways a way to actually try to do proof checking that might be applicable in an algorithms class or maybe a logic class. And in this example, the goal is to say prove that the derivative of e to the x is actually e to the x plus x. And what the student is given here is the assumptions and then a set of rules that they can apply to the assumptions to get to the goal. So what happens here is that we have a software that developed by Colleen and other people at Stanford to help the student guide them through this step process, this multi-step process. And each step, the proof checker checks whether your next step of the proof is a valid step in the proof. And if you can get through all the valid steps to the final answer, then we know that your proof is correct. So hopefully this is going to open the doors to many other ways for us to do evaluation and assessments, many other ways for us to integrate deeper core math concepts and into the online systems. And so finally, another example here that I like to show you is an example from database class. So in the database class that we teach, one of the most important things in the class is to learn how to work with the SQL query language. And so, but to work with the SQL, but to understand and really learn how to use the SQL query language, you need to write the queries. But to write the queries, then you need to have a SQL library. You need to have a SQL whole setup on your local machine to do it. So instead of having all of that, what we have done is also to allow instructors to develop workbenches like this one, where students can actually enter queries right into their browser, run them, and then get immediate feedback on what their query does. So in this case, the question is to find all movies directed by Steven Spielberg, and then the query could be something like, select title from movie where a particular condition holds. So this really simple and interactive experience was really critical for the database class to actually succeed. So we have similar exercises for XML, for JSON, for all of that too. Cool. But so we're going to look at a bunch of examples from very math and science classes. But now you must be thinking, but education is not only limited to that. How about the rest of the classes? How about classes in history, poetry, writing, design? How about all those things, right? And for those things where we have more open-ended work, we have also thought really hard about it and thinking and how we can grade these things and how can we give students feedback at scale. So over here, I'm going to show you an example of one of the classes that we have called the Gamification Class and how we have thought about this whole process. So normally in a class like gamification, a student would be asked to submit a single essay. For example, essay on gamification online courses. And in a traditional classroom, what you would do is to get 5 to 10 TAs, this army of TAs, to grade all the 200 essays you have in the class, right? But if you think about it, that's okay for a 200 student classroom. But what if you have 10,000 students? What if you have 100,000 students? That's no longer feasible. You're not going to find 1,000 TAs to grade everything. So instead, what's critical to notice in here is that the classes are big, and since there are that many students in the classroom, why not just leverage the community itself? Why not leverage the crowd? So for these assignments, what we had thought through and designed was a peer grading system. So your first step is to submit your own assignment, your own write-up, but then you're not done yet. The assignments are complete. The next phase of the assignment is for you to then go and read, and other peers, right? And then grade their assignments as well. So first submit your assignment, and then grade your peers' assignment. And if each student in the class were to grade 5 other assignments from their peers, then every assignment would have been graded 5 times, right? Therefore, everyone gets a lot of feedback, and that's a really good way for us to scale grading. I think the big question to us, is does this work, right? It's a big, at scale especially. So to answer that question, I'm going to show you some interesting research and results. So in 2006, Sattler and Good did an experiment in education in smaller classrooms of a few hundred students, where they had students peer grade each other. And in their experiments, what they found was that there was a really high correlation between peer grading and what the teachers gave as grades. And so, in a small classroom, this seemed to work for them. But what's more interesting for them was that they found that self-grading, the self-evaluation, self-critic, was actually slightly higher correlated than peer grading. So there's some sense that, self-grading actually works pretty much better. But these experiments were done at a scale of 100, 200 students. What does it like if we had 10,000 students, right? What does it like if we have 2,000 students? And so we did the same experiment in one of the classes that we had, the sociology class. And what you're seeing here is a graph of over 2,000 submissions of the sociology midterm, where students were to write essays on a particular sociology prompt. And for this class, the staff for the class, the TAs from, I guess in this case, Princeton, were kind enough to actually sit down and grade all the 2,500 essays by hand. That's pretty crazy, I thought. And this is what they came up with. This is what the results look like. So peer grading results versus the staff grading results, they were really highly correlated. And this gives us a good sense that this peer grading methodology can possibly work and could be further improved. And I think it would be a good way to go for open-ended work in the future. Cool. And I think two other things to know about peer grading, I guess. There are 3 things in peer grading that I find really appealing to our students and to the whole learning experience. So for peer grading to actually work for students, the first thing is that they have to really understand the material deeper and deeply to be able to grade. So that requires them to think more critically about the material. Now, number 2 is that while they are grading, they are being exposed to all other students' work and being able to read different opinions and what other students have done. And that really opens up the horizons of what you learn in class. But what's really interesting is number 3, that every essay that you get, gets peer graded multiple times, and therefore every student on their own essay gets multiple feedback. So compared to the past, when they only get 1 feedback from a TA, now they get 5 feedback, 5 feedback responses from all their different classmates. And I think that's really powerful. Cool. So that was about meaningful assessments, and I hope we can, in the near future, we develop much more of it. But let me talk a little bit about community. Question before I go there.
Yeah, are you expected to grade 500 people's work, or is it just 1 person and you get 5 people?
It's a great question, right? So the question was, are you expected to grade 5 other works, or do you want to grade just one, or how many do you grade in particular? So we thought very deeply about this, and it's a problem of how do you allocate submissions to grading, right, to students to grade. And so one of the things that 2 things that we thought about, first thing is that there's no reason to limit it to 5. And as on the internet, there's a very long tail distribution you find in most places. And so what we did was to allow students to grade as many as they like. And in some of the classes, I think the HCI class, where the work was a design, to submit the designs, we found that one student actually graded 70 submissions. Right, so you actually find, so this really amazing student, she actually graded 70 submissions, and we looked at the logs, and she ended up spending about 10 to 15 minutes on each submission. So she actually seriously sat down, read through them, graded them one by one. So there are students out there who would grade, an incredible number of submissions. But as to your question on how we do allocation, that is I think it's an interesting technical algorithm problem that we face at the back end, right? How do we do allocations? Do we do it beforehand, on the fly, just in time? And at Coursera, what we decided to do was to do just-in-time allocation. So at the point of time when we say, I want to grade a student, I want to grade a new peer assessment, at that point of time, we look at all the submissions, find out which submission has the lowest number of peer grades now, and then give it to you with some probability. And you can think about ways of improving this in the future. For example, maybe actually find submissions that are have the most disagreement in the grades and get more graders for that one. And so this is something that we're looking into developing further. Cool. Question in the back.
So the graph you showed. Was that on a single rating, or was that on?
I see. So the graph I showed, this graph, I guess, the peer grade is a summative score that we generated. So the way we computed peer grades in this case was, I guess it's a really naive algorithm which we're trying to improve, is that for every grading criteria, we take the median of the grades given by our peers. And so the median is really robust to outliers. Right? And then we use that, and then we sum up all the components of your scores, and that will be your final grade. But you can always think of, I think that's the first step in, in peer grading, and you can think of various methods of doing rater reliability estimations and so on that we like to do. Question there first, I guess.
Do they have any kind of answer key when they're doing the?
Depends on the course. Some courses do have an answer key, some courses don't. Yeah. Sorry.
Have you seen people trying to gamify the system and kind of like what?
Yeah, so we have seen people in the system doing two things, I guess. One, giving everyone full marks, which we kind of filter out right now. And number two, copying answers from other students, right? So there's some plagiarism going on. So there's those two ways of sort of gamifying the system. And to all of that, we're thinking of many solutions for that. Various ways to detect plagiarism. That's one thing I'm thinking of. I want to be careful in doing that. And various ways of, estimating how reliable a grader is. But because of the way we do allocation of graders, that's random and it's, in this particular statistical fashion, it's really hard to gamify it because you do not know who you're going to grade. Unless you create 1,000 accounts, which we will then find out and block you off. Yes?
Would it make more sense to maybe weight the grader to look at them and say, grader always give them a horrible grade, and to try to weight more heavily the graders that are more reliable?
Exactly. I think that's a great idea and something that we're looking into. And not only to weight them based on, so I think if you can weight them based on how reliable they are, and reliability can be estimated by, how much they agree with everyone else. Right? If they disagree with everyone else, maybe they're not reliable. Right? But exactly, yeah. That's something that I'm thinking about. Cool. Okay. Yes, let's go on. Okay, so community. So the other big aspect of online learning, I think, is community. And to give you a sense of what community looks like today, this is a graph showing the community in the sociology class. So every marker indicates a student. And so I guess the sociology class was kind of a huge experiment in sociology itself. And so, this shows the students from all over the world, and this was a graph that actually the students generated by having themselves contribute to their locations on a shared map. So it turns out that community is really important for online learning, but in really particular that this sense that there's a cohort of students, there's a people who are doing the same homework and assignments as you, working through the same difficult problems, really gives a very motivating sense for you to try to complete it as well. And not only it gives you a sense, but it also gives you help. So over here, I'm going to show you a little snapshot from our forums, which actually shows, a particular question on a student facing problems installing a software. And what we notice is that there are many other students on the platform who really quickly would respond to the students who posted the question and give really relevant and good help. So in one of the classes, in the machine learning class, we saw that the median response time to the forum, a new forum post, was about 20 minutes. So if you think about it, if I was to go to a forum right now and I write a post, in about 10-20 minutes, I'm going to see a response to my question. And never have I seen that happen. This kind of response time for an actual in college university class, right? A 10-20 minute response time is incredible. But with the scale that we're working at, with the number of students in the classrooms, this is possible. And what's perhaps interesting is that, again, in the forums, you see a long tail effect. And again, a small number of students will be generating a lot of responses and high quality posts. And that's what really drives us to be able to do these large classes. Cool. So with all of that, with all the ingredients in running a class, what can we do next, right? Where do we go in technology? What's going to happen next for learning and education? So one of the things that happens is that by running classes online, we are able to track to a very fine detail every single thing you do on the classes. And that gives us a lot of data And from there, we can basically learn about learning and see how education, what's the optimal way to teach, hopefully get closer to it. So I'm going to show you two results here that hopefully give a sense of what is possible with human learning, with all this data. So this is an experiment that we did in the machine learning class, where what we did was to visualize all the incorrect student answers to a particular homework. So in this homework, you had to implement a function that computed the gradient for a particular cost function. I think it was logistic regression. And so what we did was to take the student's code and then run it through unit tests to decide whether their answers were correct. And what we did here was to take all the outputs of the students' submissions that were incorrect and then plot them on a 2D visualization. So over here you can see very clear 4 big clusters of common misconceptions, right? So 4 big X's there. And they correspond to different simple errors, for example, missing out a bias term, not writing the formula correctly, or missing out a half in the equation. And what we were able to do based on this insight as the next step was actually to then customize how our systems could respond to the student. So, normally in an online system, you submit your homework, you say incorrect or correct. But what we could do in this case was to go a step further and say, hey, you submitted this particular solution, it's incorrect, but you might want to consider this other factor, right? But you might want to consider looking at your bias term. And through that, we were able to give students very much more personalized feedback on what they were doing right and doing wrong, and then they could actually correct their solutions and keep going on from there, making good progress on their work. So that's one experiment. And let me show you another experiment that we did, that John Huang worked on, and who did on looking at how quiz submissions or how people go through the website, how we could look at that and garner insight. So what I'm saying here is a timeline of what a normal student experience would be like. They might hit a quiz, they might get an incorrect submission, they might come back again and try to submit again, they might get it incorrect, and finally, after some more time, they get the correct submission, the correct answer to the question. But with all the data we're collecting, what we're able to do is not only look at this timeline, but also fill the gaps. So what if what if looking at this data and we find that a student, when they go to a quiz and get an incorrect submission, what they do next is actually to say revisit a lecture or revisit a forum and try to get help. Would that help them in their understanding? Would that help them in their route to learning? So what we could do in this experiment was to, for each forum post, estimate what the probability of transitioning to a correct response is, given that the user has viewed a post. Right? So let me show you one of the results from the experiment. So one of the posts that we focused on was this post in the forums on a particular function that the user had to implement on compute costs. And the first user got it wrong and was asking for help. And then the next user who responded, who got really highly voted up, said that something like, you might want to consider that the first column of the matrix has all ones. So when we looked at this forum post and looked at this and how it correlated to the actual questions, the quiz submissions, we found that the number of students, if they actually viewed the forum post and then went back to the quiz and tried to submit again, 0.6, a probability of 0.643 of them would get the right answer after that. And on the flip side, if they did not go to the forum, then 0.34 of them would get the correct answer. So this gives, for the first time, I think, this gives us insight into how a student browsing the website is able to learn better, is able to get the right answers. And what we could do from here next is perhaps to encourage more of the same behavior or find different routes in the learning paths of a student that we want to optimize for. Cool. So I talked a lot about what course online courses and what we have learned from it. Just question in the back before I go on. With the forums, how do you manage it? See. Because will that increase the percentage of the correct answer? So that's a good point. Someone posts the correct answer, then everyone should get it right? But it turns out that, so one nice thing about the whole online learning experience was that we are finding that we are building up a community. And the community that we built up is one thus far that has been really collaborative, supportive. And when we have seen posts of the answers before, and what happens in those cases is that people downvote those posts really rapidly. And and that student, that student who sees that, then after that normally modifies his post, deletes the answers, and everyone will jump in and say that, hey, don't do this, this is not part of the honor code. This is part of the honor code. You shouldn't be doing this, And normally the self-regulation that happens get rid of those posts very fast. But moving forward, that's something that we think about a lot. And how can we reduce or eliminate the possibility of potential cheaters? Yep. But cool. So I'd like to tell you a bit more about the software stack, since we are at the ACM conference here. So this is what the software stack at Coursera now looks like. So on the front end, for any front end developers here, and it's cool. And so we use Backbone.js. So if you use that, do come by, talk to me later. And we use Backbone.js in the front end to write our really JS heavy MVC framework in front to serve out our application. And we use Python, Django in parts of our backend, served by Memcached and MySQL. And as we move forward, as we keep growing, we've been seeing an increase in the number of services we're developing. And that's where we're bringing in things like the Play framework runs on Java, and using Zookeeper to manage our services. And all of this runs on Amazon's web services. Sorry. Oh, analytics. Good question. So we collect a lot of data, and I'll be frank with you and say that we don't have a huge analytics team right now. But we do collect a lot of data in the eventing server that runs on Play. It's actually implemented in Scala, if you're interested. And most of our analytics today are done through, we use a few tools, including BigQuery from Google, to do most of the one-off analysis. We also plan to use Hadoop MapReduce on our data that we collect. And that's mostly it, I guess. Yeah. So Hadoop MapReduce and BigQuery. Yeah. Cool. Thanks. So what goes behind Coursera, and what are we worried about today? What are the challenges at Coursera? So this is a nice graph to show you the growth of where we're going and how fast we're growing, and just barely from May to September with this steady growth and the nice spiky pattern which corresponds to deadlines. And we found that we're starting to hit really peak loads of 6.9 million page views in a day, and having loads of handling over 660 requests a second. So while this is nowhere close to Twitter or Google scale, this is pretty at a stage where one simple setup doesn't work anymore, and we're starting to diversify the way we do the backend and to scale up our infrastructure. So and what is really interesting to note is that at our peak loads, at any point of time on the site, you'll see about 7,000 to 8,000 simultaneous users. So these and all these users are always really engaged in the material, either doing the quizzes, doing their pre-grading assignments. And what occurred to us, in the recent weeks was that we cannot actually, we need to have a really robust system and stay up almost all the time. So what happens is that when we had a blip, last week and 2 weeks ago, when we went down for just 1 minute, so just 1 minute, the site stopped responding. We got about 100 angry emails from students saying that I can't submit my quiz. So it's pretty incredible that the amount of service guarantees that we're going to do because we're in education, because we're actually doing quizzes and assessments that can affect people's lives, is that having a really good uptime is really important for us. So one of the big challenges is scaling. So another big challenge that we face at Coursera is with social. So one of the things in that online learning, right, you're all online, so you don't just see people face to face. But at the same time, learning is inherently a social activity, right? You learn with friends, we have study groups, right? We have classes that are so big so that people can work together, group projects. So how can we make learning even more social? That's a big challenge to us to think and innovate on. And what we're seeing here is a picture that of offline study groups that people have formed. So this was a picture taken for the HCI study group in San Francisco. But what would be really cool is that can we bring these group experiences, can we bring these social experiences onto the web as well? Right? Can we connect up a study group that has a student in India, in Russia, in China, and in the US, and in Europe, put them together in a group and have them study together? If that is possible, I think when we connect people across the world this way, we'll be able to invent and build really new things and share experiences that are really valuable. So where are we going from here? What are the challenges and where are we going next? So in more of a technological standpoint, the few big challenges for Coursera are things to do with social learning, how to make learning more social. And on top of that, we're thinking really hard about things like how can we do collaboration, in fact, particularly like, for example, real-time collaboration. So for example, many of you might use Google Docs, and Google Docs is great when you have 10, 20 people editing it at a time, maximum. What happens if you have a class of 1,000 users? What if a class of about 10,000 users? What if they're all working together to write a textbook? how can we enable such collaborative editing at scale? So beyond that, thinking of things about advanced assessments, which I showed you a bit of. We're trying to think about how to go in next steps in that, making our website more interactive, and of course looking at big data analysis and scaling up our infrastructure. So if any of you engineers in the audience are interested today, do talk to me about these things. Cool. So I guess one question at the end is, why are we doing all of this? What motivates us, right? And the question that at Coursera we ask ourselves is, what if we could offer a free, high-quality education to everyone? What would that do, right? I think it would really help us establish education as a basic human right. And then anyone, with the motivation or the ability they'll have the opportunity to go out and then study and learn these materials and really improve their lives, their community, and the people around them. So that's the first thing that, that really drives us. And on top of that, what Coursera does is to enable lifelong learning. And it's kind of a shame that, after college, when we graduate, most of us are probably not going to take any classes anymore. And the fact that we stop learning there is a kind of a shame, and there's always new technologies, new things being developed. And what we hope to do is to keep these classes up online for anyone to take, so that, even after you graduate and after you get to a new job, you can further your skills and keep improving. And finally, if we can bring talent around the world together, if we bring talent everywhere, hopefully we can spot the really talented people maybe in Africa, or maybe the next, Steve Jobs might be there, or someone who could really help build the next big thing in technology and help change our world. Okay, let me one last slide before I get to questions. So I'd like to introduce you to the Corsair team. So this is all people on the team, including Jacob, who's up there, the front-end engineer. And thanks. So yes, and you might be there too. Okay. Cool. Okay. So maybe I'll have us. Great. So let's go questions. Let's go there. I think you were first. Yes.
On the previous slide, you showed about how the traffic was growing or more people are using this site.
Yep.
You also mentioned that it's free for people. How do you plan to pay infrastructure to the university that are in your system covered, or are you going to charge people?
Oh, I see. No, so it turns out that, so first of all, the universities do not pay for traffic. Okay? So Coursera does all the hosting and all the streaming of the videos. So it turns out that in last month, we actually streamed out 350 terabytes of video data, which is pretty incredible. And to answer your question on how do we plan to make this sustainable, I think that's the question. Like, what is our business model around this? So one of the core missions at Coursera is the idea that students come first, right? You want to do education, and what's most important is students. So in all our decisions that we make, we think of what is best for the student. So in many of our students that come to the Coursera website to learn and to learn and take courses, what they want to do is to find new skills, and hopefully through that get a better job or get a promotion or better their lives. So if we could help students, find better jobs and find the best, brightest students, and then link them up with the employers who are looking for the right talent, then students could benefit, the employers would benefit, and hopefully in between, through that placement service, we could also benefit. So that's one thing that we're looking into. And on top of that, I think we have a dozen other ideas. And another idea that we're looking into is, how can we make the Coursera courses have more weight? Right? We can do any kind of certification for them. That's another idea too. Sorry, I think let's give the guy the back.
One of the points you made at the end of your prepared speech was about how you wanted to leave the courses online so that people can access them at any point. And so and submit it, and the answer to that, can you leave those?
Okay, interesting. So what can we leave online? How will we keep our services running? Will they always be available? That's kind of like the broad question there. Yeah. Yes. Yep. So I think with the programming, I think there are ways to make the programming workbenches work in the long term, and the way to do that is through auto-scaling. Right? So if we can auto-scale all our systems, and that's a challenge for us, if we can auto-scale them so that if no one's using it, it goes down to 0, there's nothing running. If there are tens of thousands of people using it, it auto-scales up to 10 servers, 100 servers, and supports the load. And I think with auto-scaling, that's something that we can look into and be able to do. So in fact, some of the classes, I think like the CS 101 class, the machine learning class, these classes are actually available in archive mode to the past students, and they can still work on the assignments on the programming assignments through the system. Yeah, so I think the hope is really, that anyone will be able to access any of this high quality education anytime they want. So, what's other questions? Yeah, sorry, guys, go you first.
The universities feel threatened by all the free courses that we offer now, and idea that students will now choose to not go to university due to the cost and just take the courses online. It's like free and all that.
I see. So I guess the model that we have taken at Coursera, so the question was, will universities feel threatened? I think the model taken at Coursera is not to be a threat to universities. It's actually the opposite. So we want to find a place that we can actually complement the universities. Or find a place that we can help the universities bring their content, bring their best knowledge to the 21st century. Right? So instead of, one of the things that you might see, and I'm not sure they're going to do this in U of I, is that one way to use the Coursera technology in the classroom is to flip the classroom. So instead of going to the classroom and hearing a lecturer, drone on for hours and hours about the same material, what you could do instead is have all these lectures online, and then the classroom time is reserved for interactive discussions. You go through examples in class, you go deeper into the material, and this could be optional sessions, but that's what you do. So hopefully, technology becomes complementary to help make education better, rather than something that goes, tries to overshows it. Yeah. Sorry. Yes.
So I've been a TA here, and a lot of courses has TA that are offered online. So before Coursera, the concept of the online classes, you just have a video lecture and then using the tools that you have shown. So the first half of your course, you show use. In the second half of your talk, you show analytics data that professors can actually make use of. Can you comment on the reception of those tools and the adoption rate?
So far as my experiences is that we have an incredible amount of reception to the tools, and professors have been really engaged in trying to make their courses better. And I think there's a huge interest in seeing how we can take what we have today and and what's the next step for it. So as you mentioned in the past, online courses have always been video lectures. One of the big changes is that we can now do assessments. And although this is a huge investment, for trying to make automated grading assessments not easy, but what is important to note is that this investment often pays off over time. Right? It amortizes over time. And if you can do it once this year, next year you can use the same system but change the variables. And next year you can do it again. And so the huge one-time payoff that pays, one-time cost that pays off over time really appeals to the professors. And that's why we're seeing a huge uptake there. And on top of that, I think on our side, we're trying to always innovate and make a simpler, easier to use interfaces for instructors so that, the friction to them to adopt the technology is lower.
Do you have one-on-one help with the professors?
So for some classes, we work quite closely with them. And for some, I think, depending on the school, I guess, sometimes the schools have project managers that help work with the instructors. Sometimes we give feedback. Depends on the class and the school and what they want to do. But we do often email professors directly. Yeah. Cool. Let me just go over here first.
Are the classes transferable?
Sorry, what do you mean?
Are they transferable to an institution?
Oh, I see. Do they do transfer credit? Is that so they are not transferable now, I think. And I think there are some classes on the platform, I think from UW, Washington, that will actually give you credit. But most of the classes are not transferable right now. It's not transferable. Sorry, yes.
You said that the machine learning classes will be taught in physical classroom and also. How does that compare, for you said I think $3? How does that compare to the rates that we're passing on or in the physical classroom?
Oh, so I would say first of all, let's clarify the numbers. So on the online class, when I said about 13,000 of students completed the class, I think the right measurement to compare that to is actually the number of students who engaged in the class. So I think I'm trying to recall in my head now. I think the number of students who engaged in the class was about 30,000. So even though we had 122,000 students enrolled, the engagement that we had in the class, many students actually enroll just to check it out, to find out what's happening, watch a few lectures, and they don't actually try to complete the class because they might not be really interested in doing so. But the number of students who actually tried to engage and completed the first assignment, I think that number was closer to about 30,000. And so of those 30,000 students, 13,000 completed the class. And in the actual on-campus class at Stanford, I imagine the rates to be much higher than that, mainly because students are actually paying to complete, to get credit for their classes, and they want to finish it. But you bring up a good point that, retention and completions is a huge problem for us, and we like to figure out what the best ways are for us to improve that. Right? We really want people to stay engaged and be able to complete these classes online and help motivate them in the right way. So that's a big challenge for us that we're looking into. Let's go behind Chris. Yes. Yeah.
So the programming assignments, they get automatic.
Sure. Okay. Sure. Yeah. So let me tell you a bit about maybe the most interesting one was the let's see. Okay, let me give you two examples. There was a software as a service class, the SaaS class on the website, which was taught with Ruby as the primary language. So students were to write Ruby code and submit it. And then what happened there was that the auto grader in the backend would take the student's Ruby code and then run RSpec, RCoff, run reverse coverage tests on it, and then run it against functions that were stubbed out, and then use those outputs from those tools that measured coverage and performance. And based on those numbers that come out of it, your code was so efficient, it did so much coverage tests. Based on those numbers, give the student a grade. So so basically, if you can think about ways to grade it, have all these coverage tests, you can actually do that grading. So that's one class. In a different class, in the graphical models class, this is a PGM class, that we had actually to learn how to write code that did base net inference, Markov nets inference. In that class, what they did was that the students' code generated a Bayesian net that was the output of the system. And then for the grading, what the instructors did was to run inference on the network generated and see what the probability of a particular event was, right? And use that as a grading method. So in general, as long as your grader can execute and do some evaluations that produce a number, you can do automated grading. And the challenge for us there is, how do we scale this up? How do we make sure it runs securely, especially if running code? And how do we make it easier for instructors to use this? What APIs do we provide?
Does there have to be a lot of interaction between?
There is, I see. Yeah, so there is a bit more interaction there because we do need to slip in their graders somehow and run it for them. But in general, because we have pretty well-defined APIs for all of this, they can develop it completely independently of Coursera. Yeah. Yes. Sorry.
How do you see yourself relative to the other two startups in this space, edX and Udacity?
See.
And that space you broke into, that's insight into that.
Sure, yes. So I think first of all, edX and Udacity, I think it's great what they're doing. The online education market is huge, right? There's this huge demand. And I think it's great that not only Coursera is trying to fill the need for it, so it's edX and Udacity. So I would say there's some different models, some different decisions that we've taken in moving forward. So in particular, the first thing that we decided is that we wanted to work with universities and not try to, change the whole system, but actually work with universities, get them to buy in, and then help work with their professors to get the best courses online. So that's the first, one of the big things that we decided on. And I think it's really a really good decision because, through that we have gotten up to 33 partners and close to 200 courses. That's amazing. And the other thing that we decided on was that we wanted to be a separate organization from the university so that we can be more independent and the universities work with us as partners instead. And I think perhaps one of the biggest thing is the way we approach, the way we approach online learning and the technology we're building. And the focus that we have, on assessments, on being able to grade and so on. I think that's been a big investment too. Let's see, I think of race, yeah. But yeah, so I think I think what they're doing is great, and with more people in the field, that will help us improve as well. Yeah. Sorry.
You mentioned that the University of Washington is starting to give universities to use for their online classes?
So for the internal classes, so with all our partners that we work with, the school has the option to use the Coursera platform for the internal classes. So, for example, at Stanford and Rice and Princeton, I know various classes there are using Coursera for internal use as well. So definitely possible. Definitely possible. Just
you spoke a little bit earlier about attrition and engagement, and I was wondering if you have any insight onto what students here as individuals can do to maximize chances of success when taking a Coursera class.
So I think the most important thing to do, this is why I'm seeing to maximize your success, is to actually have a set schedule on when you do things. So what I see is that most students online, that when they actually say, hey, my homework is due on Monday, and I'm going to set 2 hours on Sunday from 1 to 3 p.m. to do my homework. And they have discipline to follow that. And those students are the ones that are most successful in their classes. Having the discipline to sit down and say, I'm going to do the work, I don't want to leave it to the end. And that's one of the biggest advice I can give. On top of that, I think, actively engaging in the class, participating in forums and helping other students out is a really good way for you to learn and understand the material, because to answer a question, you first really need to understand what the question is about and what the material is talking about. And through answering questions is a great way to learn the material. Sorry, the back, yes. So we are VC funded by KP and NEA. Venture capital funded. So 22 million in total so far? Yes, there are. I think we are kind of at the brink of what's possible. And this is like a first step into what online education could look like, what seems to work. But clearly it's not what a really integrated experience feels like. Clearly it's not the feeling that I know what's going to happen next. I can click on and be brought through the course in a very intuitive fashion. So we are thinking very hard about user experiences, how we can improve the interfaces, what a natural user flow through a course is like, how can assessments be more integrated into the video, right? How can the whole thing look like more like a single piece rather than multiple pieces where you have everything separate. I see. So we leave most of the decisions now to the partners that we work with. So our university partners decide most of the time which courses they like to put up, and we work with them to help them figure out what makes most sense. So we haven't really had that experience yet, so can't really speak to that. But again, I think the process is that we'll talk to the partners again and figure out what makes sense for them, what they're comfortable with, and move from there. Yeah. Cool. Hey. That's it. Yeah. Okay. Cool. Thanks. Thanks everyone. Thanks everyone.